Okay, so right now I'm gonna demonstrate to you one of the product that coming with our LTE SDK, which is LTE analyzer. But we are not going to demonstrate all of the features yet because it's kind of a new prototype. But don't worry, because we will demonstrate one or two of the main feature of this analyzer. Basically, this analyzer will be used to analyze the LTE signal previously generated by the SDK. But before we can use this analyzer, we have to choose the data output to be fetched as an input for this analyzer. So let's get to it. The first thing that you have to do is click the set path button and then navigate yourself through the bin directory of the LTE SDK and choose the output directory. By default, the installation directory was in C program files LTE framework, but if you use 64-bit operating system, it will be located in the program files x86 folder. So let's click this folder and find the LTE framework. Okay, and then you will find the bin directory, and if you successfully executed the LTE SDK previously, there will be an output folder. So let's just click this output and then choose OK, and then after that you have to choose which frame and subframe that you want to analyze. So let's say right now I want to analyze the first frame, which is index 0, and I want to analyze also all the subframe. So it means that I have to set the subframe max index into 9. Okay, and then I will choose what analyzer mode I want. So if let's say if I want to analyze the power spectral density, I will choose this PSD option and then choose the bandwidth mode. Let's say I want to 10 megahertz and then click draw. And then let's just wait for the analyzer to work. Okay, so this is the power spectral density of the LTE in the 10 megahertz bandwidth in the first frame, and you can see this is the correct power spectral density for the LTE 4G release 9. So this is a single frame power spectral density for the LTE 4G, but if you want to analyze just a single subframe, you can choose this subframe maximum same as the minimum. So let's say I want to analyze the first subframe. Let's just select the subframe minimum index into 0 and choose the subframe max into 02 and then click draw. Okay, so this is the first subframe plotted right. Also, if you want to analyze the last subframe, let's just fill this subframe minimum into the last index, which is 9, and do it too with the subframe max index. Choose it in the number 9 and then click draw. So this is the last subframe of the first frame should looks like. So the next thing that I want to demonstrate is the two-dimension resource allocation map. To enable this mode, you have to select two-dimension resource allocation, and then you have to set back the minimum subframe index to 0. Now it means that we want to analyze the resource allocation map for all of the subframes in the first frame. So let's just click draw and let the analyzer work. So here we go. This is the two-dimensional resource allocation for the first frame, and for this vertical axis, this is the frequency domains of the map, and for horizontal axis, this is the time domain. And you can see there is a red dot section. This is the cell RS0, and then for the orange block, this is a PBCH channel. So here we go. So if you want to analyze more detail about, let's say, the PBCH channel, you can just show the PBCH subframe into this plot. So I will make this subframe smaller, so I have to set the subframe maximum value to, let's say, just 2, and then click draw. Yes, and then you have you will have a better view about the PBCH block in the resource allocation map. If you still want more detailed view of the maybe this block, you can just reduce the subframe max value in here, hit the 0, and just click draw, and you have the full view of the first subframe of the first frame. Now you can see that the PBCH channel positioned in symbols of OFDM number 9 and also 10. Okay, so that's it. That's the end of our LTE analyzer first demonstration guide, and thank you for watching.